Hey developers, ever wish scrolling your web page could feel like directing a movie? Like you're the camera operator, smoothly guiding a full 3D scene. That's exactly what we're diving into today. I'm a UI developer, and I've wrestled with this in real projects. So I'm not just showing you flashy demos, I'm sharing the exact technique I use to combine threejs with GSAP scroll trigger. Will make your scroll drive a 3D world like a total pro. In this part, we're adding professional shadows and a subtle floor to ground this 3D model. Critical techniques that transform floating objects into realistic scenes. When this video hits 200 plus likes, I'll pin the full source code in the comments. Your support helps create more content like this. Let's examine our floor and shadow system line by line. First, we declare two variables, floor shadow and floor tint, both initialized as null. These will store our shadow catching surface and visible floor plane. The function add floor and shadows takes one parameter, box, which is the bounding box of our 3D model we calculated earlier. This box contains the model's dimensions and position data we'll use for precise placement. Inside the function, we start by creating our floor geometry using three.circle geometry. With two parameters, radius equals 8 units and segments equals 64. The radius should be large enough to extend beyond our model, while the segment count balances smooth edges with performance. Next, we create our shadow catching material using Three.js with an opacity option set to 0.22. This means the shadow will appear at 22% opacity, subtle enough to look realistic without overpowering the scene. We combine these into a mesh called floor shadow. To position it horizontally, we rotate it around the x-axis by negative. Pi divided by 2 radians, which equals minus 90 degrees. The critical line floor shadow dot receive shadow equals true enables this surface to catch shadows cast by other objects. For positioning, we set its y coordinate to the model's minimum y value from our bounding box plus 0.001. This tiny offset prevents z-fighting, those flickering artifacts that occur when surfaces occupy the same space. Finally, we add this to our scene. Now we create the visible floor with floor tint. Using the same geometry, we pair it with a 3 MeshStandardMaterial. For its options, color equals 0xEFF3F9, a soft blue-gray that matches our background. Roughness equals 1, completely matte surface, and metalness equals 0, non-reflective. We position this exactly at the model's minimum y coordinate, box.min, y, and add it to the scene. This dual-layer approach gives us a barely visible reference surface that enhances depth perception, while the shadow catcher creates realistic contact shadows where the model meets the ground. And that's how professionals create grounded 3D experiences. We've transformed our floating model into a physically present object with realistic contact shadows. In our next video, we'll complete the cinematic look with 3-point lighting. You'll learn how to set up hemisphere, lights for ambient fill, directional lights for dramatic shadows, and dial in perfect fog settings for depth. If this shadow technique improved your scene, please smash that like button. When we hit 200 plus likes, I'll share the full source code with production-ready settings. Press like so more developers find it. Subscribe if you want more practical UI animation breakdowns that you can ship to production. Subscribe to the channel for more CSS tips. See you in the next video.